In our laboratory, we focus on vascular and cardiovascular. So we build blood vessels and heart tissue all from stem cells. And then something we've been focusing on the last few years is adding in the fabrication of the tissue, the biomaterials that we want to use to build three-dimensional tissues and organs. So an undergraduate student that would join our laboratory, the benefit is that they get a feel for what research is all about. And it becomes very clear to them whether this is a good fit, whether they enjoy it. And so by giving them these experiences, it helps them make a choice about what they want to do next. The grad student's different, and the graduate students, ideally, they already know, they love research. So my job is to teach them how to do it, how to design an experiment properly, how to write a research proposal really well, how to publish technical articles. And so by the time they're finished, I hope I've taught them all of these things so they can go out and be an independent lead investigator.
Dr. McCloskey has provided her support in listening to my ideas and also getting me into contact with other faculty members who can help me expand on my research. I decided to stay in the McCloskey Lab because it's a wonderful environment. It's really conducive to research. There's a lot of teamwork. I feel really welcomed by the other graduate and undergraduate students. I appreciate all of the training that I'm receiving.
I find this line of research very fascinating, and ever since I started joining and working in her lab as an undergrad, I just found a passion for it. I was very drawn to the fact that you could engineer or guide these stem cells towards a specific fate and eventually acquire these cardiovascular lineages.
I chose to join McCloskey Lab because I have a strong interest in tissue engineering. My research focus is with pluripotent stem cells specifically. Basically, we take cheek cells and we turn them into stem cells, and then we turn them into heart cells.
My research focus is simply mending broken hearts. I'm trying to develop a device to use it as a platform to study repair mechanism in the heart. The heart disease is the #1 killer in the world, killing over 2,000 people just in the United States every single day. And the economic burden of cardiovascular diseases is somewhere into $400 billion every year in direct and indirect costs to the country. So if we have a way to repair cardiac infarctions, that is a very big contribution to the field, economically and also health-wise. Through the years that I've been here, I've had a lot of growth in me that I know I see and other people see also, as a researcher, as a mentor, as an educator, and as a leader in my community. So I'm very thankful of this opportunity to be here and grow in those aspects of my life.
So we have tons of outreach. So myself, I'm part of the CCBM programs here at UC Merced. Through the program, we actually bring in high school students, we bring in middle school students, and over the summer we actually have training programs where we allow them to get hands-on experience in the lab. So our lab is very unique because we sit at this crossroads where we can combine a lot of these medical applications to create these complex structures. And yet, we're flexible enough to actually allow these starting out scientists to actually get hands-on experience. In addition to that, we also do and perform tons of tours for anybody that's interested.